Welcome to our new unit. We are learning about energy. Energy is going to be one of the more challenging things for us to understand conceptually because it's really hard to pin down exactly what energy is. Something like velocity, we can point at something and say, if it's moving fast, it has a lot of velocity, or slow, it doesn't have very much. It's easy to quantify and it always looks pretty much the same. Energy exists in so many different forms and can do so many different things that almost the only definition that we can give for it is the fact that it exists in so many ways. So here's my best attempt at a definition for it. You'll find other ones online. Um, to me, this tends to be the most useful one. So energy is a quantitative. It is a quantitative property of the ability to change. Meaning, quantitative, we can assign values to it, and we're looking at whether something can change itself, change others, change the environment. All of those things are some form of energy. Uh, so there's the definition. As I kind of said, it's not particularly helpful. But let's talk about some of the different types of energy. There are a lot, and I'm not really going to get all of them here, but I will get many of the ones that should probably you should be aware of. So types of energy. The first big type of energy is going to be kinetic energy. This is the energy of motion, and it's one of the big ones that we'll actually deal with directly in our class. So, kinetic energy exists in a couple different forms. We have translational. That is when something is moving from side to side, left to right, front to back, up, down. Translational is motion from one spot to another. There's also rotational kinetic energy. That is when an object is spinning. It's not moving from location to location, but relative to itself, it is moving. And there's even one more form of kinetic energy, vibrational kinetic energy. Vibrational kinetic energy is actually both vibrational and rotational kinetic energy are actually super important to chemistry. Vibrational being things like the bonds that move back and forth, or we go back and forth in different ways. So those are the different forms of kinetic energy. We will primarily be dealing with translational, and we'll talk about rotational to a small extent. We won't talk about vibration at all, and even rotational. Uh, Similar to air resistance, a lot of the time we're just going to ignore it, or we'll set up problems where rotational doesn't really matter to us. But those are some of the big types of energy. We also have gravitational potential. Gravitational potential energy is the idea that if you lifted something up and put it up higher, it now has more of a chance or it will hit the ground faster than it would have at that lower spot. So by putting it up there, we changed something about it. And the thing that we changed is energy, because anytime we're seeing energy, or anytime we're seeing something change, we can assign a value to it because it's some form of energy. So there's gravitational potential. There's also spring potential. And that is like if you have a potential, if you have a spring and you compress it or you stretch it, you have some energy that you didn't have before. Um, these guys together all make up a form of energy called mechanical energies. Sorry, writing sideways is hard. Uh, these are mechanical energies. They're the ones that matter most to us in this class. They're some of the forms of energy that have been understood for the longest, which means they're really good starting off point in an introductory physics course to start wrapping your head around this difficult idea. But there are lots of other forms of energy as well. I'm going to write them kind of more briefly. There's chemical potential. That's the type of energy stored in chemical bonds. There's nuclear potential. That's the kind of energy stored within the nucleus of an atom, similar in some ways to chemical, but where chemical energy is stored due to the electrostatic force, nuclear energy is stored due to the strong nuclear force. There's also electrical energy, which we'll kind of talk about a little bit this semester. There's electromagnetic. Oops, I'm taking over that red box a little bit. Electromagnetic. There's sound, and there's thermal. All of these are probably ones that wouldn't particularly surprise you. Thermal's probably the only one off this side that we're going to deal with to any degree. And we won't even do too much with it except to acknowledge that as different processes happen, some of the energy gets turned into thermal. And once it becomes thermal energy, it's very hard to turn it back. We can say that thermal energy is a non-conservative energy, that once it goes there, it's probably stuck there. It's different than gravitational potential. If I lift something up, I can get that energy really fast back out. Thermal, once it's there, it's stuck. So these are just some of the forms of energy. You may have heard me mention the word potential a lot of the time. Potential is a type of energy that requires multiple objects interacting with forces that are internal to the system. We'll talk about that more later. But big ideas that we want to keep in mind here. We have these different types of mechanical energy that we're going to learn to describe really well, and then many, many other forms of energy that also exist as part of our definition, as part of our understanding. If you want to change the energy of a system, we have something called work. And work is not a form of energy, it's a way that energy is added or taken away. It is a way that energy can be added or taken out of a system by applying forces to it. So we'll be doing a lot of stuff with these mechanical forms of energy, with work, and then kind of just be aware of some of these other forms of energy. So the last thing that we're going to talk about is just a quick example of some types of energy or some energy shifts as this car goes on a quick little trip. At this point right here, the first one, we have this car sitting at a gas station, or not a gas station, at a stoplight. And at that stoplight, it would have all kinds of chemical potential because it has that gasoline stored inside it. And then as it speeds up, here it's going to start having some chemical or some kinetic energy because it's moving, chemical potential, kinetic energy, which means that the chemical potential is going down because gasoline is being burned and turning into that kinetic energy. Then it goes up this hill. That's probably means that we're losing more and more chemical potential energy. And depending on how you're pressing on the gas pedal, you may or may not have lost kinetic energy, but we definitely would have now gained some gravitational potential energy that we didn't have before. And then finally, if we slam on the brakes to get to the stop sign, that's going to generate some heat in the brakes, some heat on the tire surfaces. And now we have some thermal energy that didn't exist before. Now, this isn't the whole story. There's lots of other forms of energy that exist here. There's probably electrical energy playing into the whole vehicle running, maybe the lights are on, something like that. There's definitely some spring potential energy involved in the shocks and the struts. Lots of sound energies can be a part of this process. Thermal energy has been produced the entire way along here. Energy, one of the hardest things about it experimentally is how hard it is to pin down. Energy tends to fly in so many different directions at once that trying to set up good experiments that look at energy can be challenging because you tend to lose energy in places that you have a hard time measuring or you didn't plan to measure. But this is good for a introduction to energy. Hopefully you have a better feel for kind of like what energy is, what different forms of energy there are. So keep this in mind and we'll keep working on it as we go through this unit.